Chapter 14. In this chapter, we'll talk about the universe. As we start getting into some aspects of our universe and some of the characteristic features of our universe, let's talk a little bit about the night sky. When you look up at the sky, you see stars, lots of them. The amount you see would vary depending on whether you're in the city or you are looking up at the stars in the countryside. Light from houses and buildings, towns, cities, all affect what we can see when we look up. The night sky is filled with billions of stars. And our personal star in our system, called the sun, is described as an ordinary star with an average brightness. Observing the night sky is not a new science. Astronomy is one of the oldest sciences. This is because this science did not really require a lot of measurements to be made. This science was purely observational in its early ages, in its beginnings. Whether these civilizations were African civilizations, Greek, they all looked up at the stars and saw planets. Stars appear as point sources. They twinkle from atmospheric turbulence. The distance measured to describe the stars from where we are on our Earth is given in light years. So traveling at the speed of light, that is, if we travel at 300 million meters per second, or 3 times 10 to the 8th meters per second, when we travel at that speed constantly for 1 year, we will travel 1 light year, which is 9.5 times 10 to the 12 kilometers. So light year is really far away. And so when we measure the distances to stars, nearby systems or galaxies, the distance of light years are used. Planets are visible only because they reflect the light from the sun. So when trying to understand where different stars, constellations might be in space, scientists have developed a system where we use what's called a celestial sphere. The celestial sphere is an imaginary sphere that exists around our Earth. You can think of this as a spherical projected screen. And on this spherical screen, all the stars are located. This celestial sphere sort of mimics our Earth as it surrounds the Earth, sort of a pretend spherical sky. And it has an equator called the celestial equator. The celestial sphere has north and south poles, and these north and south poles align with the Earth's equator and poles. So the celestial equator, the north and south poles align with the Earth's equator and the Earth's poles. So it's angled the same way. It's just nice big sphere that's around our Earth. And remember, this is not a real sphere, it's imaginary, but it's just sort of a projected screen where scientists can put the stars on. And the point of doing that is so that we can identify a location for a particular object in the sky. So if we're standing on Earth at any point, directly above our head is 90 degrees because it's 90 degrees are perpendicular from the flat surface, which is here in green. And that point is called the zenith. And we can turn our body around, we can spin around this green flat area, and that's changing our azimuthal angle. And the north is 0 degrees, and we can move around counterclockwise to get the azimuthal angle. And then we have to look up, which is called our angle of inclination. So if we know the azimuthal angle and the angle of inclination, we can determine where a particular object is, in the case of a star, for example, is in the night sky. So since we're looking up, sometimes this is called the altitude angle. And the altitude angle and the azimuth angle are the two combination, or the pair that we need to determine a location of an object on the celestial sphere. And of course, there's a celestial meridian, which is sort of east-west location of the observer. And objects appear to rotate about the north and south poles. So we have in our Earth, directly in line with our Earth, is a star called Polaris. It's in the same axis of rotation as the Earth. And so at the North Pole, if scientists were to look up at Polaris, they will not see Polaris move, but they will see everything move around Polaris. So we'll probably talk a little bit more about this in chapter 15, where we talk about the solar system. But, among some of the things that the ancients talked about was the location of the Earth in the big picture. And early Greeks, philosophers like Ptolemy, taught that the Earth was the center of our system. And that's because, from our point of observation, everything moved around the Earth. So this model of the solar system with the Earth at the center is called a geocentric, geo for Earth. So it was a geocentric system. And that was really widely accepted, and it sort of worked together with what the church thought at the time, that everything was focused on Earth and the people on Earth. Later, another scientist named Copernicus came along, and with his observations and some of his calculations, he was able to predict that the sun was actually at the center of our system and the Earth was orbiting the sun. So the sun being the center, it's called a heliocentric system. And the Earth orbiting was not quite widely accepted, didn't kind of go with what the church thought at the time. And so this was a very controversial topic. All right, so that's a little bit about what we see when we look up at the night sky. We see stars and we see planets, but there are some other things out there too that we will talk about. And we'll do that in Unit 2.